So here we go. There is, just to remind everybody again, I put some more notes, deadlines, and things like that on the schedule. I sent out some announcements about that. Just in case you didn't see those, here they are. And today what I wanted to cover was functions. But if you have any questions about the earlier material, you can ask them now. Yeah.
Just in trouble on activity 2 on conditions, the exercise 1.
Exercise 1, this one? Would you mind if we look at your code? Is that okay?
Yeah, sure. I had some help earlier, but I'm not sure if it's...
Is this you?
Yeah.
Yeah.
Oh, no. It's FH.
FH? Right there.
Yes.
Okay. It's this one here? Okay. So you want to ask for an X and a Y, read them in, and then calculate an average, and then take the sign of the average and then print the result. Now the first thing to do here, well, I don't know if it's first thing, but one thing we could do is compile, just to see if it compiles. Looks okay. So it just zips right through there, huh? I think it's this syntax right here is a little funny. This is what happens here, this line here, this, you're using a syntax, you're using a form, a pattern, which is doing something that's not what you think. So this here is an expression. Actually, what has higher precedence? This operator, this is an operator, this comma is an operator. So we've got two operators here. So which operator has higher precedence? I think this has higher precedence. I believe that has higher precedence. So I believe what's going on, and I'll just comment that one out, I believe that what's going on is this, that this executes first, and then this operator is applied. Now, what do they call this? This operator is almost never used. It's like a sequence operator. Let's see here. Functions. I'm going to go to, here's the table. See the table and operators. So there's lots of operators, and this is a, this is an obscure operator that people don't really use much. So the compiler accepts it, but it's doing something that you wouldn't expect. Here's a table of operators. These have the highest precedence, the highest importance. They're the ones that evaluate first. And you'll see that well, let me show you down here. It has the lowest precedence. Look at that. It's the bottom of the table. That's the very last thing that you do. Just to verify this, you know that multiplication, see? That's multiplication. Well, all the forms of multiplication. There's multiplication and division and remainder or modulo. Those are all like forms of multiplication. And then you have forms of addition. And so addition has a lower precedence, that multiplication is applied first. If you don't have parentheses that control the order of operations, multiplication is going to be done first, and then addition is going to be done after that. So you can see that the order here, the arrangement of these operators go from higher precedence to lower precedence, and this would be the lowest precedence. And it's called they call it, what do they call it? They say precedence group. It's a sequencing. It's the comma operator. It has left to right evaluation. You see, most of these operators are evaluated left to right. There's a few that are evaluated right to left. You do the operator on the rightmost operator, do that first, and then the next, then go in the direction toward the left. So this sequencing operator, it doesn't do much. It just, it takes whatever is on the, it evaluates what's on the left-hand side and pretty much discards it, and then evaluates the right-hand side, and the total expression, you've got A comma B. All right, A comma B evaluates to whatever B evaluates to. That's it. It's like trivial, right? So this is what your code is doing. You're reading in X, and then you're just throwing a Y out into air, and it just disappears. Another way to show how this works is like this. So I'm showing you different forms. These are all equivalent statements to what your code does. See, it's the same thing. You do this, and then you do that. Well, that's not doing much. Am I beating a dead horse here, or am I helping you understand this? Am I talking too much? I don't always know. Okay. So that's how you look at this stuff. So that's why when we input it, the system took the X, but didn't take the Y, because there was no input operation, storing anything into Y. There was only a single input operation, and then we just jumped right into here. I believe that Y was probably 0, although we don't know what Y is because it's uninitialized. But it was probably 0. And then the average would be 2. And what did I typed in a 2, right? Anyway. So what you really wanted to have here was this. This is what you wanted. Ask for Y, it's a 2. X is 2, and Y is, say, 3. You see that? Okay. It's not like a human. A human can read this and say, oh, I know what he wants. He wants to store, read in an X and then read in a Y. The system isn't doing that. It's like, oh, I got a comma operator in there, and it applies the rule, without any understanding. It's just mechanical. So you actually have to pay attention to a lot of little details, and you can't make assumptions about how the system is understanding you, and it's not that smart, although it is getting smarter all the time. So newer languages would might spot that as an error. They might not have a comma operator, and they would say, oh, that's a syntax error. It's, newer languages are a little bit more helpful than this old language, C++, bit old. And also I want to say that this, I think, doesn't the problem ask for double floating point values? So I think that should be a double. I believe that should be a double. Prompt the user for 2 double precision floating point values, X and Y. So you don't have to use X and Y, but it would be useful to use X and Y, and you are using X and Y, but this is an int, that should be a double, okay?
So
double, yeah. I mean up here, up in line 8. And everything else looks nice. Looks good. The rest of it is good. All right, so I'll let you carry on there. Any other questions? We'll jump into functions. And also, I didn't know how to solve that input problem. Remember, I was trying to clear the bad bit and last week. I'll show you the solution to that today. But I'll do it in the context of functions. So I'll make it relevant to what we need to learn today. So functions. A function is a named block of code that can be executed by calling the function. When you call a function, you pass in 0 or more arguments. The following illustrates the syntax of a function definition with a simple example. So we're defining a function print here. It takes an argument x, and we can invoke it like this. So we call the function. We've already been using some function. We used the sign function already. We use the rand function. We use srand. We use functions related to the string class. So we've been using functions. You know, a function represents some complex operation, and which is, you know, it's just it's a big activity. We say, all right, function run, do your job, and when you're done, return back to us, and then we're going to carry on from this point where we called you. So now I'm going to show you, these are all simple examples of different kinds of functions. And then I'll talk about this stuff here, like constant reference. That's important. Forward declarations. So this, it's not too bad. It's easy to get it figured out. Is this me? Yeah, I think that's me. So here's some code. And this says hello. I want to come back to this problem where we asked for x, and then we read x, and then we asked for y and read y. The prompt, I'm sorry, that's y, it should be x. Hold on. So we ask for x, we read in x. We ask for y, we read in y. And then we'll print something. X plus y equals something. It equals, sorry, x plus y, like that. That's close to what we were doing last time. X is 2, y is 3, x plus y is 5. All right, that's working. But if we run it, and we enter in RTY, that's what we did last time. I think it was RTY. And it just skips right through there. Everything is a 0. It didn't even ask me. It didn't wait. Although it prompted me for y, it didn't stop and wait for me to enter anything in there. It just ran right through there. And let me tell you what's happening here. So first we output x equals, and then we make a blocking call. It's called blocking because the system waits there. It's waiting for the user to type something and then press the enter key. When you press the enter key, there's a buffer. You know, as you're pressing keys on the keyboard, these keys are getting into let me call it the input stream buffer. And then when the user presses enter, you sort of flush out that buffer, you push that stuff through. And that's when the input operation takes place. Although the input operator doesn't necessarily take everything out of the buffer. And that's what's happening in our case. When we type in RTY, this CIN, I think it may pull off the R and leave the TY in the input stream buffer. So here, it's waiting. And as I'm typing, RTY, and then I type in, I'll call it the new line, this. I type a R, then a T, and then an enter key. This is the enter key. Enter key generates a new line, usually. I mean, depends on the context, but I think that's safe to say it generates a new line character. And this is like this is like a line, a queue at the grocery store. It's a line. This is the person that's, at the checkout paying for the groceries. And then this is the next person waiting in the line. See, there's a third person waiting in the line, and then there's someone at the very end of the line that's going to, do something. So these things are queued up in this input stream buffer. Now, X was declared as a double. So this input operator, what it's doing is it's reading in character data, and it says, well, I have to convert this character data into numeric data and store it into this variable X. But the user has entered in a value that cannot be converted into numeric data. It should be a 9 or an 8, or a 0 or minus sign. Minus sign is acceptable. But in R, it's not expecting an R. So it's like it has a nervous breakdown. So it says I can't handle the R. And then it goes into a fail state. And then it just sort of refuses to do anything. We were correctly, clearing the fail state last week. But what we didn't do is we didn't clear out the junk remaining in the input buffer. So that the next time we tried to do an input operation, we're operating on the junk that's left over. The input operation was allowed to go because we cleared the error flags on the input stream. But we didn't clear the junk out of the input buffer. And I want to demonstrate that to you here, which I haven't done yet, but it just occurred to me that I could do this, and I'm going to try it. That when this fails, what we can do is first we clear. We're going to clear, that clears the bad bit, the error flags for the input stream. And then let's call GetLine. I think I can do, how do I do it? How do I use GetLine? I know this is one way to do it. I'm not sure this is how we want to do it. Is that going to compile? Let me see. GetLine was not declared. Is this right? I just can't remember.
I don't think there's an underscore.
Just no underscore. Try that. Expects 2 arguments. Expects 2 arguments. So let me go back. Let me try this. I think what's the first argument is like a string. Is that going to work? Programming by guessing, you know, shouldn't be showing you this. Expects 3 arguments. And, all right, I got to look it up. You know, it's also a member variable, but we can do it like this. Oh, this is a delimiter here. It's read everything up until this delimiter, but this should work as well. This one should work as well. I think that's a good one to use. Let's try that one. Let's try that one. Let's do this. There we go. All right, so we do RTY, and I hit enter. Now, I don't know, is it gonna, if it gets the line, oh, we didn't print it. Wait a minute, we gotta print it. We need to print this. So C out, I wanna see what the line looks like. And I'm gonna add an endle there. So when this thing runs, what's it gonna print? I'm going to type in RTY. I didn't hit enter yet. Okay, I'm going to hit enter. What's it going to print? So we're basically pulling everything out of the input stream. So do we pull out RTY or do we only pull out TY? That's what I don't know. So I'm going to make a guess, and all of you should try to make a guess as well if you're following this. You know, when this is the thing that fails, C in input X. Okay, this command fails because it can't convert an R to a number. Does that mean it has removed R? Has it pulled R off of the input buffer? You know, or has it left R in there? What would you do if you were going to define the language? That's how I do my guessing. It's like, well, what would I do if I was going to create and define this language? That thing's vibrating a lot, isn't it? What the heck is going on? Is that bothering you? Can you see it vibrate? It's just me. Okay. So I'm going to guess it returns RTY, but I'm not confident. I feel 50% on that one. It is RTY. I got it. Okay, I won the bet. So what we want to do here, see, that's why when we cleared the input buffer before, and then it wasn't good enough to read the Y because RTY was still in there, and we're going to do the same input operation on a double variable Y. It's going to have the same result. So it doesn't, just clearing isn't good enough. Let's watch that fail again. Not good enough. What we need to do is get rid of all the, we could do this. We could do this. We could just do GetLine and then just, you know, not do anything with the characters. Let's do that. That'll solve the problem. RTY, enter, Y, 3. So, you know, we got it. Well, I mean, it doesn't really, it's not a good program. Well, X is, you know, happens to be equal to 0. We didn't initialize it to 0. We could have, but that's normally what happens is you get a 0 in memory by chance. So this like flushes out that input stream. Now, you know, there's another way to flush the input stream. This is a little bit wasteful because we're allocating a variable and filling it in. But it's still a way to do it, and it's probably a way that, you know, we could do. Maybe this is a good way to do it. We could call this better, we're going to do to discard. You know, that's a better variable name, discard. That's the characters we're going to discard. Just pull them out, store them in a variable, and then don't use it. It's like garbage collection, you know, like going into a landfill. But there's another way to do it that maybe is more less hacky, but it's hard to quite understand. It's there's a, what the heck is that name? There's another. It's not reset. It's what's the what is it? I need to find the input stream. Input output here. Input stream. And these are these flags we're talking about here. And here is the, there's the input operator. That's the GetLine function. And that's clear, we call it clear. And where is it? It's in here somewhere. Oh, ignore. Here it is. Ignore. Extract and discard characters. And it's hard to understand this. This is the n, and the default is 1. This is the number of characters, the maximum number of characters to read and discard. And then delim, that's the delimiter. That's this where you stop, and you hear it stop at the end of file. These are the defaults. So I think we can just do something like, see, these are functions, by the way, and they have default values. So the second argument is called delim. It's an integer. And if you don't supply the argument, then the compiler will assume you're passing in EOF, which represents end of file or end of the stream. I don't think that's what we want in this case, but that's there to think about. And the first argument, n, has type stream size, which is probably int or a long int. And it has and if you don't supply a value for n, the compiler will assume you're passing in a 1, which means you only want to discard one character, maximum one character. You know, this, you don't see, this is, once again, this is an old language, and it's a little arcane and a little hard to work with. You know, newer languages is much easier to work with, I've got to say that. This is just hard. This documentation is hard to read. You don't really find good, easy to read documentation on C++. It's just hard to do. But in newer, once again, take a language like Swift, you know, like the new language for iOS and OS 10. You know, I don't know the language. I haven't even looked at it, but I'm sure that language is a lot easier to use than this old language here. Anyway, let's call, what was it again? Oh, ignore. We're going to ignore, say, 256 characters. Put this some power of 2, some a reasonably big number. And this EOF, that's the default EOF. Here, the default here, once again, I told you was 1. If we just pass in nothing, it'll call it as if it was this. Now in the file, I think that's, that's different than the new line. So end of file means it's the end of the stream. And I don't think that's what we want, but let's see what happens if we let EOF go in there. I think it's not going to work, but I didn't try this, and I'm curious to know what happens. So it's RTY. Yeah, see, that's not working. So what we need to do is give it a delimiter, and we'll use the new line for that purpose. So discard characters all the way up until you reach a new line. And discard the new line as well. I don't know, does it also discard the delimiter? I think it also discards the delimiter. But we'll find out. It still doesn't work. What's going on? Oh, 1. Sorry. Sorry, it was only discarding the R. And we tried to input into Y, it read a T. So that's what's going on there. All right, good. Lost faith in my presentation for a moment. And this is going to be, say, a 3 there. Now it's working. Okay. But, what would you rather use? I mean, this is, like I said, this is wasteful. And also, by the way, GetLine reads until it hits a new line. So these have the same effect. It's nice that this is one line. This might be a little easier to understand. I'm going to go with the one line here. So and we don't want to always do this. So it's only if there was a failure. So if CN is in a, I guess they call it a fail state. And I used not good last time, but now I'll try fail. I mean, I don't think people use these that much, to tell you the truth. Let's see, fail. Check whether either the failed bit or the bad bit is set. Good. Check whether the state of stream is good. End of file. Check whether EOF is good. I think this is fail is all right. Bad bit, fail bit, and bad bit. So I don't know, the fail bit and the bad bit, there's some difference there. I'm just going to go with fail. I don't want to dig into too many details. So if the input stream is in a fail state, let's clear it and discard what's in there. And then we're going to go forward. So if we run it without, with valid stuff, we don't want to have to execute this code, although I think this is harmless. But if we type in invalid code, it won't break. So that's, this is kind of a long story here. And I don't usually cover this topic in this class, but I don't know, I cover different things every time I teach it. And also we got stuck on this last time, so I thought I'd show you how to beat this thing till it's finished, okay? And let's see, so this isn't good enough for what we need to do is here, because what we want to do is we want a loop. Did we do loops? We didn't do loops. Okay, but I'm going to do a little loop here. A loop means repeat. A loop is a way to repeat a block of code. So here's a block of code. We want to repeat that forever. So this is the loop condition up here, while true. This is a loop condition, and we're just saying the condition is always true. So while the loop condition is true, repeat the block of code. So this is called an infinite loop, and this is all I'm going to do on loops. This is all you need to learn for now, because we're going to probably do this in the next session. So this thing here, what I have set up means repeat this forever. So we need to get out of here somehow. So what I'll do is that. I'm going to prompt the user for X. I'm going to read it in. Okay? We're going to do this forever, unless we break out. We're going to ask the user for X, read into X, check the fail bit. Check to see if the input stream is in a fail state, not the fail bit, but the fail bit and that other bit, I forget the name of it, bad bit, whatever that means. So if the input stream is in a failed state, then clear it, and then flush the input stream. And that's it. Don't, this is else break, so we're not doing else. So if fail returns true, means the input stream is in a failed state, then we're going to clean it up. And then what do we do next? Well, we do this next. We're in this loop. So we're going to keep repeating. So if the user types in something bad, we're going to keep asking for it. We're going to ask for it until the user types in something good. See? Now, when the user types in something good, this expression evaluates to false. If the user types in a 3 and hits enter, the conversion from characters to a numeric value succeeds. And so the input stream remains in an unfailed state, in a good state. So this expression that I have highlighted here, C in fail, evaluates to false. It's not failed. So if this is false, we don't do this, we do this. Because it's if that, then do this, else do this. So we're on the else side now, okay? Break, and break means get out of the loop. So we jump out of the loop. So I want to show you how this works. Let's try it. Oh. This has to be declared. Do you see the problem? You know what, let me go slowly here instead of just fixing it right away. What is the problem here? This is very important. What's that? Yeah, initiation of X. The declaration of X is on the inside of the loop. Now this is called scope. We declare X there, okay? Now X is not visible here. If I did this, if I did this, can I do that? I'm using X before I declare it. So the compiler is going to refuse to accept this. It's going to say, hey, when it gets to line 10, and the compiler works sequentially, it's going to get to line 10 and it's going to say, input into X? What's X? You didn't tell me what X is. Oh, what I'm going to tell you later, well, that's not good enough. You've got to tell me what X is first, and then you can use it. So that's that, okay? Now, but look, X is defined in a block of code. The block of code starts here, and it ends there. So that means this X defined here is only visible there. That's called the scope of X. Only code in this block, in this scope, can access X. But when we try to access X here, right there, it'll fail because it's undefined. Look at this, see? X was not declared, and look, it helps us out. It was declared, but it wasn't declared in this scope. And look at the line number, it's line 24. It's line 24 right there, right? So it's this X, that's not the variable X, that's a character. We could put anything there, that doesn't matter, right? That's just a character. It's the variable X here. That X, the compiler is saying, You didn't declare this x in this scope. It's not say you didn't declare the x, you didn't declare it in this scope. So let's solve the problem. And declare it. I gotta bring that indent over like that, okay? So there it is. We declare the x here, and then we use it. And then we can use it again down here. Now we'll run the program. RTY, enter. It's asking for x again. DDD, enter. 23 SDF. It took it. You know why? Because it found the 2, and then it found the 3, and said, that's good. And then it got an S, and it said, oh, S, oh, that must be the end of the number. And it set X to 23. And it left SDF in the input stream. So then when we got to line 21, the input operator said, oh, the input stream has something in it. It's got an S in it. S. Now I go into my fail state. I left the S in there. So what we need to do is copy this whole thing down here. We got to repeat the whole thing for Y. So I typed in 23 SDF. Let's try that again. X, you know, this doesn't work, right? But if I go 23 SDF, X will be set successfully to 23. But Y, see it said Y equal, and then what did it do? It printed Y equal to, see why it printed it twice? Because it prints it first, right? And then it executes this line, but it's not it doesn't block because the input stream has got an SDF in it. So it tries to pull the S out, and we go into a fail state. And then this code runs, and we discard the SD and F from the input stream and reset the fail bit. And then we prompt again for a second time. That's the reason why we have Y equals twice. So we got to enter in something else, like say a 6. 23 plus 6 is 29. All right, now look at what we got here. Is there any questions on this? Here. You guys following this? It's pretty, so many details, right? You got to be really detailed to get into this. You got to be really detail oriented. It's more fun when you're doing it yourself. I want to tell you right now. It's easy for me to explain this to you, and it's fun actually, you know. So, but when you're just sitting there watching me, it's maybe not as fun. But when you start digging in, doing it yourself, you can get into it. It gets to be a pleasure actually. So, unless you don't like this kind of stuff, I mean, that's not for everybody. Right? But for a lot of people, they can. It's like playing a video game. Just wake up, have a little breakfast, and then work all day till late at night and then crash. That's how they do it, just like an engaging video game. Anyway, coming back to this, this is where I want to motivate functions. We've got duplicate code. This block of code is so similar to, I mean, they're the same thing, just the variable is different. One is X, the other is Y. So this is kind of wasteful. Like, what if we had a mistake here? We wanted to, you know, like 256 wasn't the right number. I wanted 1024 or something, you know, instead. Then I got to come down here and make sure I've got the corresponding change down here. And also, it's just more to read. It's a lot more to read. It's duplication. So we can use functions to get rid of this duplication. So what we'll do is we're going to have a function. I'll declare it up here. This function returns a double. So we want the function to look like this. We're going to do, it's going to simplify our code immensely. It'll look like this. Declare the double, and then instead of executing this block of code here, we're going to call the function. We're going to go x equals, say, read double. Just that. And then we're going to do the same thing for y. We're going to read double and store the result in y, and then we're done. So this thing, this read double, this function has to, this expression, when we invoke the function, the expression has to evaluate to a double, because that's what we're going to store into y. So what the function evaluates to, the data type a function evaluates to, is shown first. And then after the data type, we show the name of the function. So data type, and then name of the function. And then we have an argument list here, but we've got nothing in here. We can put things in here, separated by commas. Or we don't have to show anything. So here, this function is not taking anything. Let's start by implementing a stub. We want the function to evaluate to a 3. I'm not fully implementing the function to do what it's supposed to do. Ultimately, I'm just implementing the function as a step, as one step towards a final implementation. So this trivial implementation of a function is called a stub. It's just used, make sure that the compilation works, make sure some of the logic that's invoking it is set up right. And then once we get this working and checked, then we'll step forward and get the full thing working. Now this junk here is going to get commented out, because I don't want to get rid of it yet. So I want to move that into the function. So here's the line that adds x and y together. Now, if the function returns 3, then we're going to get x plus y equals 6, right? So here, this read double function, this, by the way, this return, what return says, let the function evaluate to a 3. That's what return means. So wherever you called the function, replace it with a 3. So this read double right here is going to get replaced by 3. So 3 will be assigned into x. Does everyone get that? It's kind of a little abstract, right? You got to use this, and then it becomes very second nature. This is not a C++ thing. Functions exist in all languages. Every last one of them. Well, that's not exactly true. Assembly language, they don't have functions. Well, sort of do. Anyway, this is read double. Let's test this. Let's test it with our stub code. I didn't have to enter anything because it didn't ask me. It just, x was set to 3, y was set to 3. We added them together, we got a 6. Now let's let read double actually ask for something and return what we needed to return. What we want to do is we want to declare a value. I'll call it v for value. Although I don't really like to use v, I like x. I don't want to confuse people there. We'll declare the v, we'll read it in, and then we'll return the v. So now the function is going to evaluate to some v that we read in. You know what? Let me use x. I'm uncomfortable. I don't want to like to use v. Sounds like a vector. X sounds like a double to me. I'm going to use it like that. But this has got the scope of this x is right there. This x that I'm declaring here is visible only here. This is a different x. This x has the scope here and all the way down to the bottom. Okay, but those are different x's. They happen to be the same name, but they're different variables and they have different scope. They don't overlap. So now I'm going to type in 3 and 4. I should get a 7. There we go. But you know, the problem with that is we didn't get the prompt. See? So what we needed to say something. We needed to prompt. We could put the prompt down here, or we could put the prompt in the function itself. Let me do it down here first. Well, actually, we have one already. I'll show you. It will prompt for x, and we prompt for y. Here's the x equals. Oh, I'm going to do Control-C. That kills it. So I didn't like the new line there. I don't want a prompt there. I don't want a new line. You out of time yet? No, not yet. There it is. X equals 3, y equals 4. Starting to look better. But now it'll fail. You know, we have our old bug in there. RTY will not work. So what we want to do is use this code here, this block, in the function. I even saved the return x here. So when we read the double, you know, it'll say x equals, which is a problem because let's take this out for now. Because we're prompting for it down here, x and y. We just say x equals here. When we want to input the y, it's not going to work to say x equals, right? We want it to say y equals. So now, when we read the double, we call read double, we go into this loop, and we return once we get a good value. So we need to break out of the loop. When we break out of the loop, it means we've got a good value in x. Now, x is not defined here. And so we use x here, and we also use x here. So this x is inside the loop, and this x is outside the loop, but it's all inside the function. So we need to declare x before the loop, before we use it. And it has to be declared outside the loop. Otherwise, we can't return it here. It's still, we're getting there. It's not quite all the way I want it to be, but it's getting there. X equals 3, y equals 4. That seems to work. But what happens if I do RTY? See, it doesn't reprompt. It just goes to a new line, and then it waits until we type in the 3, see? That might be good enough. But let's suppose we want to repeat the prompt over and over again. How are we going to do it? Well, look, we have a different prompt each time. This is the prompt here, and here's a different prompt. So let's pass the prompt in to the function as data for the function to use. We can do that with functions. And also, the other thing I'm going to do is just let's declare and assign x in the same line. To me, that's just easier to read, and you can do it like that. Like we just have nice 2 lines right there. So now we're passing in the prompt to the function as an argument. So the prompt is a string. I'm going to call it a prompt, like that. And so before we input the value, we're going to output the prompt. This is how you declare, functions have output and they have input as well. This is how we declare or specify an input. And you can have multiple inputs, by the way, separated by commas. We could pass in an integer I, for instance, and a double Z. But we don't need those in this case. We only need one. We're only passing in one value prompt. So this is the input, and this is the output. The output is a single value, or nothing. Running out of time yet? We're getting there. Yeah. So now we're outputting the prompt here. Let's see if that works. X equals R2Y. X equals. So it's waiting. So now maybe this is the behavior that we wanted. And look at the main. Look at what we had before. Look at this. Look at this stuff we had before. Look at what main looked like. And look at what main looks like right now with functions. How much easier it is to look at that and understand what's going on. It's a 3-liner now, because we put the logic in here. And now the code is not being duplicated. We have the same block of code. Now, in this, you should be reading through here, hopefully. Functions that return void. This is just simple. You can read this and understand that. It means void means it doesn't return anything, so we declared a function as void. Functions that return values, that's what we're working on now. This is a function that returns a value. Default parameters, we looked at that with that ignore function in the documentation. If a prompt isn't passed in, we could say like this. If the prompt is not passed in, we'll say enter a number. So watch. So in the first case, we pass in x equals. In the second case, we pass in nothing. So in the second case, the compiler will pass in enter a number for us, because that's our default assignment. X equals 3, enter a number 4. So that's how that works. That's called a default parameter. Now, pass by value versus pass by reference, this is a little trickier. We'll talk more about this next time. And you might want to read this in advance. This is called a reference. When you pass by value, you passing in a value x here. The compiler makes a copy of x. We operate on the copy, but when we pass in a reference to x, we're not making a copy of x. We're referring to the x that's in the, which appears to be in the outside scope from where we called the function from. And then we're modifying that x. So a copy is not made. So in this case, we don't need a copy. So we just say, and this is not absolutely needed here, but it's what you would generally see. We're saying that, we're just going to, don't make a copy of prompt. Just use the prompt that's, elsewhere. Let's see this. This has got to be, let me see if that fixes it. I got to declare it as const because I don't have time to go into it. That's the problem. We'll talk more about this next time. Let me leave it just like this. I don't want to get you too confused there. I just keep it like that. Any questions on this? Is that overload? Not too bad. Const references. Next time, it's all written up here. It's pretty straightforward, I think. And, well, not that straightforward, but pass by value versus pass by reference is extremely important. You must understand this completely if you want to go forward with the subject. You have to understand this. Const is pretty straightforward. It means you can't modify the thing. We're passing in name. This is a const string reference. That means name cannot be modified in the function. That's what it means. Name should be constant. That's what const means. It's a promise. You say, I promise inside this function not to modify name. I promise to treat name as a constant. And then if you try to assign something to name, the compiler is going to say, you broke your promise. You said it was const. You're trying to modify it now, so I'm not going to compile your program. I'll report an error. So the purpose of declaring things const is to avoid logic errors. Because something is intended to be constant, tell the compiler to make sure it enforces that limitation. I'm dumping a lot of stuff on you today, and that's it. Any questions? Nope, that's it. Okay, that's it.